MAM School of Engineering, Department of EEE, online classes, subject Digital Logic Circuits, Unit number 3, Synchronous Sequential Circuits. Uh, Today we are going to see, in this chapter we are going to see about the shift register. It is the one of the application of synchronous sequential circuit. That means we are going to store a value using the shifting concept. Okay, we are going to store a value in the shift concept. Okay, we need to know what is the shifting. Okay, so first you have to know the shifting. So for example, in digital concept 1000 we have, if you are shifting right means it will take it will reduce the 10, so that means it will be 100. So that means 8 converted into 4, so that means we are dividing the 2. If you are shifting left means we are multiply with the 2. This is the concept we are using in the shifting method. As well as using shifting we can store the datas zeros and ones to the next flip-flops. Okay, so register is a memory. Okay, generally we have 4-bit register, 8-bit register, 16-bit register, 32-bit register and 64-bit register, like that we have. Using this we can store the data of processing and we can store the output data. A shift register is a digital memory circuit found in calculators, computers and a data processing system. So bits enter the shift register at one end and emerge from the other end. The two ends are called left and right. So flip-flops, also known as bistable gates, store and process the data. So application of shift register, that is computer and data communications, serial and parallel communications, multi-bit number storage, sequencing, basic arithmetic such as scaling. A serial shift to the left or right will change the value of the binary as a power of 2. Then logical operation, like that they are using for the application shift register. So parallel with serial. So serial communication provide a binary number as a sequence of binary digits one after another through one data line. So parallel communication provide a binary number as binary digits through multiple data lines at the same line. It's the concept with the serial communication and parallel communication. So shift registers are devices that store or move bits from in the serial left to right. So like this. This 0 will be moved to the here. So another data will be load. So like that it will be shifted. So parallel means we are giving the input as well as we are getting the output. So parallel means we are giving the parallel input and the parallel output, like that we are using. So ideally in shift register the binary digit transforms, that is shifts from the output of one flip-flop to the input of the next individual flip-flop at every clock edge. Once the binary digits are shifted in the individual flip-flop will each retain a bit and the whole configuration will retain a binary number. So construction of a shift register. So shift register are constructed from the flip-flop due to the characteristics, that is H character devices, output state, retention. So if each flip-flop in a shift register can retain one binary digit, for instance, if a 5-bit binary number need to be stored and shifted, 5 flip-flops are required. Each binary digit transfer operation requires a clock edge. So asynchronous inputs are useful in resetting the whole configuration. So example of shift register construction. So shift register are comprised of a D flip-flop that share a common clock input. So this is the common clock pulse input given to this one we are giving the common clock pulse to the all the D flip-flops. So here we are giving the input, here we are getting the output, depend on the application of shift register. So there are possible combination of data transfer methods are, that is 4 type of shift registers are using for data transfer methods. One is serial in serial out, another one is serial in parallel out, next one is parallel in serial out. So final one will be parallel in parallel out. So serial in serial out flip-flop shift register. A serial in serial out shift register has a single input and a single output. Okay, that means we are giving the input here, we are getting the output here. So in the intermediate, we have to get the init data. So after 4 clock pulse only, you will get the first data. Okay, this is a concept. So after 4 clock pulse only, you will get the first data. So after 8 clock pulse, you will get the whole data. Okay, this is the concept like this. Here we are using 3 flip-flops. So after 3 clock pulses only, you will get the first data. Okay, this is the concept of serial in serial out. Next, serial in parallel out flip-flop shift register. So that means input is given to the first flip-flop and output get from the all the flip-flop end. Okay, it is also connected with another flip-flop as well as you can get the output. Okay, so when clock pulse is enabled, the first input is loaded, it will get the output. So next clock pulse given means first one move to the second one, so that output will be loaded. Okay, here also after 3 clock pulse only you will get the output. That is serial in parallel out. So parallel in serial out, we are giving the parallel input to the flip-flops through the direct values. So after first clock pulse, so all the values are loaded into the D flip-flop. Next clock pulse, so it will be goes to the next one. So in between they are connecting the OR value. So OR depend the which bit we are going to send. Because here we are using OR. If it is 1 means output will be 1. If it is 0 means output will be 0. So like that they will define. That is the concept of output. Next, parallel in parallel, mainly used for the parallel communication. We are giving the input in the parallel concept. We are getting the output in the parallel output. So if you are giving 1 clock pulse means output will be there. Thus this is the concept of parallel in parallel out. So initial shift registers can be configured to operate in a variety of modes. For instance, they can be configured to have either serial or parallel input and output. This is a concept. Okay, so example for JK shift register. So previous one we used with the D. Here where they are using the JK flip flop. So same as here, two input and one output like that they are using. Okay, because in D flip flop we have one input, one output. Here two input and one output. So these are the shift register we have used. Okay, shift register mainly used in the concept of storing the data and retrieve the data from the some registers. In microprocessor, they are using for arithmetic and logical operation to store the values. Using this register, we can perform and know the status of flags like that. We can know. Okay, initial shift register having modes like that forward, reverse, that is right shifting or left shifting, and serial or parallel input and output like that they will define. Using a JK flip flop and SR and T flip flop will define the shift register characteristics. Thank you.